All right, so here's an example of 2D particle equilibrium. Okay, I've got a spring that has an unstretched length of 200 millimeters. Okay, it's got a spring constant shown there, 800 newtons per meter. And then I've got all my dimensions on there. I want to find the force in each of these two cables. So the first step is always to draw a free body diagram, which I have right here. I've got three forces. I've got my spring force, and then I've got each of these cables, okay, heading off in that direction. I don't know these two, so I just label them FBD, FBC. I do know their angles, so I throw those in. They're going to be in tension going out that way. Okay, this 240 comes from the fact that I know K is 800, and I know the unstretched length is 200, and my current length is 500. So S is just going to be 500 minus 200, so 300 or 0.3 meters. Multiplying that times K, which is 800, gives me 240 newtons. That's where this came from. Okay, and that spring's being elongated, so that spring is pulling on B. Okay, so here's my free body diagram. Everything's labeled. Now I simply sum my forces in my x, sum the forces in my y. So the sum of the forces in the x is going to be BC cosine 45, 4/5 FBD, both of those in the positive x direction, and then I've got negative 240. So that's the sum of the forces in the x direction. I set all of that equal to 0, those three forces equal to 0. In the y direction, I have, again, opposite, so it's going to be BC sine 45, and that's acting up, positive. And then I have the vertical is 3/5 FBD, and that's heading down, so negative FBD 3/5. So here are my two equations, two unknowns, FBC, FBD. Okay. This relationship comes from the y equation. So I take what I know about FBC, plug it into this equation, and I get my two answers, 171 and 145. So again, free body diagram, put all my known and unknown forces in there, sum the forces in the x direction, set them equal to 0, sum the forces in the y direction equal to 0, and then solve your system of equations.